Okay, we have here a 2000 Honda Accord special edition, I believe. It's a 2.3 4 cylinders, and we're gonna be working on it. Checking light on, and needs to go for a smog. So I'm working here today on this 2000 Honda Accord 2.3, and history about behind this is the customer said he took this vehicle to a shop for and they said the O2 sensor was faulty, so they replaced the O2 sensor and the code came back right away. So apparently, I don't know what happened there. He took it to another shop, and this guy said they installed the incorrect sensor, so this second shop installed the Denso O2 sensor, and still the codes come back. So this guy were requesting diagnostic time for pretty much they said it may have a wiring issue or computer. So at this point, you know, we're gonna start from scratch, checking for codes and then going through the diagnostic. First we're gonna check here, checking lights on. You can see here, checking lights on, and we're gonna check for diagnostic for the codes right now. Just gonna use a generic scan tool. Normally it's a pretty simple. When we have something for the O2 sensor, you know, we gotta jump into with a voltmeter later. DTC 2, redness not complete. 4, this is very important because someone cleared the codes here and we don't want to be in the corner here. And just say we're gonna fix this one, and after you run those monitors, other checking light come back, you know. And that's it for sure. We're gonna tell the customer we're gonna fix what it is here right now on those monitors not wrong. We don't know if there's any issue. We're gonna protect ourselves in advance. Okay, so then you got 2 codes, read codes. Tell is Honda. So we got one generic P0135 O2 sensor here circuit bank 1 sensor 1, which is upstream before the catalytic converter. And it has another one, trunk axle control module control circuit. P1738. Shoot. Okay, so at this point, man, I don't know if fixing this heater O2 sensor problem, and now we have a transmission issues. We're gonna focus on that one right now, on the heater O2 sensor only, and then gonna go through some testing there. Now we're gonna clear the check engine light, and we're gonna see if that code is a hard fault or it's not a hard fault. So if the code come back right away, that means it's something is occurring right now. If the code takes long time, you know, that one, it means like you gotta go through a dry cycle and to the computer to detect that one. Okay, we're gonna be checking here for the heater circuit. First I see the O2 sensor is new and it is Denso. I was checking on the bottom of the sensor. It has the Denso letters, and I checked the part number, and it is correct for this vehicle. So now we're gonna check for the heater circuit. So here we have 4 wires. I'll put it this side. We have 4 wires here on the O2 sensor. So normally the white on the sensor side, the white color is ground, and the blue is a signal for the sensor. And then on this side we have 2 blacks. Normally the two blacks are for the heater circuit. The two colors are the same usually. Some of them are white, gray, whatever the two colors are, that's the same color, those are for the heater circuit. In this case are two black. So without checking a wiring diagram, we already know that. So that what I'm gonna do right now is check for power coming in to the fuse, I mean to the O2 sensor, air fuel rate sensor, and then going out on the two. I'll do it on the side is going hardness side, not on the sensor side, so that way I'm eliminating the possibility to wire to be broken. So I'm connected here to a ground with my test light, and test light is illuminating. The key is on the vehicle, so like we can see here. So we have, I don't know if this one is power coming in or going out, but what I wanted to see if on the two sides of the sensor I wanted to see power, so that way it means power is coming in into the sensor and the power is coming out, telling me the integrity of the circuit here. Okay, so we're gonna check the other side. Okay, so that means power is coming in and going out. Okay. So we're gonna move to the next test. Okay, so I have this connected here to the heater O2 sensor is unplugged, and we're gonna be checking for resistance here on the heater circuit. So as we can see, this one is showing 1.3 ohms. At this point I haven't checked for the ranges they are giving us for resistance, but what can trip this code is if the resistance on the sensor is too low. We're gonna say, for example, like 0, so that will increase the amperage on this one, and that one can trip that code for circuit 2, or open resistance on the sensor. But that one, if that one will be open, that one, what will happen is the voltage wouldn't come in and come out, and we have that one, voltage coming in and voltage going out. Okay, so I don't know, 1.3 ohms is okay. However, we're gonna check the specs for that one, but I'm not suspecting like a sensor issue, because as we remember, the original sensor was tripping this coil, so they took it to another shop, to a shop where they replaced the sensor, and then that one didn't fix it, and they installed a third sensor. So we're gonna be checking for wiring and computer at this point, but anyway, we're gonna check for the resistance on this, the values that manufacturer is giving us. Oh well, probably it's gonna be very difficult because I'm working upside here and the glare is terrible, but we're gonna try here. Okay, so go to Mitchell here, and we're gonna enter the information of this vehicle. Some 2000 Honda Accord SE, into repair, and I will just type in here the code P0135 and search. I just wanted to see the values of the resistance. Okay. P0135, heater O2 sensor malfunctions. Okay, the flow chart is telling us this. However, I wanted to see resistance. Go to the fuse, connectors, matching resistance. Okay. 3 and 4. However, I don't see the values. Oh, maybe that's just telling me here. It's the continuity for 2 to 20 ohms. 10 to 40 ohms. This thing's thirsty here. Okay. Look at this here. Is there 10 to 40 ohms? 10 to 40 ohms. What? So it's looking for 10 to 40 ohms? And we have 1.3 ohms. The engine, it is saying the one should be 2 to 20 ohms is the F23A4 engine, ultra low emission only, but we don't have ultra low emission here. Let me check for something. We're gonna compare here to all data because normally what it does is Mitchell is giving you for different vehicles. Yes, bear with me here. Well, this is interesting because what I'm looking at here is it is telling me the same thing on all data. Measure the resistance, and it's saying if it should be in between 10 to 40 ohms. Okay. If it is F23A4 engine, ultra low emission should be between 2 to 20 ohms. Okay, but we don't have ultra low emission engine here. This is because Honda has like a, right here they have like a 5 type of engines, you know, like F23A1, 2, 3, 4, and 5. So we don't have the F23A4. I'm gonna check that one here on the engine. As we can see here, we have F23A1. And we don't see the ultra low emission. Is the only one is different. Apparently this sensor is for ultra low emission then, because I got 1.3 ohms. So at this point, what I'm gonna do is I'm gonna substitute the O2 sensor then. How do I do that? I wanted to substitute the O2 sensor. I know I'm gonna get curves. How do I do that? Because I have 1.3 ohms. Okay, let me see. We're gonna think a little bit how we're gonna do this. I just went and got another sensor, and the resistance are totally different than the one I have here. Mine's one about 1.3, 1.24, 1.4 ohms, and the one I got is like 15 ohms. I plug it just to see if the computer didn't like the current. However, the coil came back right away. I'll show you what I got here. So I just plug it like this because, you know, the resistance didn't match. However, I still got the same coil. I'm gonna check the resistance, compare and show that. this is the new sensor. It's a 15.5, and I got it here, checking the resistance on it through the two blacks connectors, and I got 15.5, but still the computer didn't like it. It's still setting the code. Weird, you know, the heater O2 sensor circuit, that one is it's weird. Well, no, why that one is 1.3 ohms? I still don't like that one, because that one will increase the current and maybe damage the driver inside the computer. Because 15, we're gonna say if the system will be 15 volts and 15 ohms will be equal to 1 amp. But if that one is 12 volts, I'm gonna say system voltage at rest 12.6, 1 ohm will be what? If we do Ohm's law, equal to 12 amps, when the system will be should be running only at about 1 amp. So we still got to replace the sensor for sure, because we don't want to increase the amperage inside the computers and cook the driver. At this point, I think the driver is cooked. I don't know if what came first, probably the original sensor. It was only the heater circuit, and they installed the wrong sensor, and the sensor damaged the computer. We're gonna do more testing to the computer now then. Well, I'm here. We're gonna check for the wiring diagram here, because we're gonna be checking powers and grounds on the computer, and basically the first test is gonna be checking the heater control circuit. So 2.3 engine size we have with ultra low. Our is not without ultra low emission. And okay, I'm gonna look for the sensors, O2 sensors, which are here on the bottom. So okay, the primary O2 sensor is this one, and this is the heater part. So we see the two black and black we have there. One is black and white and black and yellow. Okay, right now we're gonna see the black and yellow. It's gonna be the power coming in, and then at this point the black and white has to go to the computer for the control side. Okay, on pin 3 go to the following, to the next one on 3. Okay, so we're here, highlighter, and it is on the connector 1. Well, this is gonna be on the pin 1, or this connector C, I think they call. Let me see, A, B, C, D, probably. Okay, I think it's connector C, they may call, in pin 1. It's gonna be black and white, and the pin 2 is gonna be white and green. So that's gonna be only for reference. We're gonna go to the computer now. Okay, gonna focus here. Connector C, pin 1 is black and white. So it looks to me like they are starting to read here pin A, connector A, B, and C. So the blue will be the connector C, and it's the pin 1. So I'm here connected to a black and white. It's a black and white. It's the pin one. For reference, we're gonna see if we are on the correct connector and pins. The next one is white and green, and the other one is red blue. White and green, and red and blue, and the fourth will be empty. So we're on the right connector. What are we expecting here right now? So what I'm checking on this is the voltage coming in to the O2 sensor, which is a power side surge coming from some fuse there, going into the sensor and coming back here to the computer. So what I'm expecting to see here is a 12 volts or system voltage. I will start the vehicle. Okay, we can see it's a 13.6. So this means this wire is good all the way from the O2 sensor to here. Now I have my test light connected to ground, and I'm gonna load the circuit and see the lights illuminate. We can see here lights illuminate, and then we can see how much a voltage drop when the lights illuminate. 13.8, 820, about 500 millivolts is drawing this. So this is a loaded test, which is telling me the system is okay. So from here all the way to there to the sensor, we have a good wire. So at this point, this computer has like a voltmeter inside, monitoring this voltage returning to here. If the computer doesn't see this voltage, it sets the checking light, and it doesn't pretty much activate the heater, the O2 sensor heater. So at this point I will turn off the vehicle, and we're gonna check for a pin contact. Basically what I'm gonna do is remove this one, and I got unplugged here the connector, and I have key on, and what I wanted to see is those voltage on the pin one here on the front, right here. So that way we can see, I don't have a broken pin or anything here, like not making contact. Let me see on the computer side too. Yeah, looks okay, the pins. So now the next is checking powers and ground, and recommended to replace the computer, and gotta be programmed for anti-theft system. Okay, so I will be load testing the powers and ground right now. We can see the pin 21 is showing with the engine running 14.2, and pin B1 14.18. So I'm here, B1, B21, okay, pin B21 and pin 1. So I won't show the whole thing here, but I will check powers and grounds of this computer, and if all are correct, the next call is gonna be replacing computer. I wanted to load a little bit, at least the engine is running right now, and we can see I have my test light connected to ground, and I wanted to load, a little bit the circuit. It's not enough. This test light is like I use it for computer testing, but we can see there is some voltage drop there. A little bit, the light illuminates. I'm loading this, and on pin 1 of connector B, okay. At this point, the next step will be I check all powers and ground already, and I know all of them are good. The next step will be to recommend replacing the computer and programming it for the anti-theft. If they approve this one, it's gonna be a part 2.